Hello students, now we solve question number 10 from the question series of IIT JAM 2024. This question based on differential equation, and the question is, let g r2r be a continuous function. Which one of the following is the solution of the differential equation d2y by dx2 plus y is equal to gx for x belongs to r, satisfying the conditions y of 0 is equal to 0 and y dash 0 is equal to 1. Here the four options are: option A, yx equal to sin x minus integration 0 to x sin x minus t gt dt. Option B, y of x is equal to sin x plus integration 0 to x sin x minus t gt dt. Option C, y of x is equal to sin x minus integration 0 to x cos x minus t gt dt. And option D is y of x is equal to sin x plus integration 0 to x cos x minus t gt dt. So let us start to solve the question. Here the given differential equation is d2y by dx2 plus y is equal to g of x for x belongs to r, and the given conditions are y of 0 is equal to 0 and y dash 0 is equal to 1. Let y is equal to e to the power mx be the trial solution. Then dy by dx is equal to m e to the power mx and d2y by dx2 is equal to m square e to the power mx. Therefore the auxiliary equation is m square plus 1 into e to the power mx, since d2y by dx2 is equal to m square e to the power mx and y is equal to e to the power mx. So d2y by dx2 plus y is equal to m square e to the power mx plus e to the power mx. So we take common e to the power mx. We get m square plus 1 whole into e to the power mx is equal to 0. Since e to the power mx not equal to 0 for all x belongs to r, then m square plus 1 is equal to 0. Therefore m is equal to plus I and minus I. So the complementary function is equal to a cos x plus b sin x. Now we find the particular integral of the given differential equation, and we apply the method of variation of parameter. So let yp is equal to, yp is the particular integral, so yp is equal to v1 into cos x plus v2 sin x, where v1 and v2 are the functions of x. So yp dash, that is dyp by dx, is equal to v1 dash cos x minus v1 sin x. That is with differentiation with respect to x plus v2 dash sin x plus v2 cos x. So we choose v1 and v2 such that v1 dash cos x plus v2 dash sin x is equal to 0. That is equation number 1. So yp dash is equal to minus v1 sin x plus v2 cos x. Now we differentiate again with respect to x. We get yp double dash is equal to minus v1 dash sin x minus v1 cos x plus v2 dash cos x minus v2 sin x. So from the given differential equation, d2y by dx2 plus y is equal to gx, or d2yp by dx2 plus yp is equal to gx, or yp double dash plus yp is equal to gx. So from the given differential equation, we get yp double dash, that means v1 dash sin x minus v1 cos x plus v2 dash cos x minus v2 sin x, yp double dash plus yp means v1 cos x plus v2 sin x is equal to g of x, v2 sin x, v1 cos x. So minus v1 dash sin x plus v2 dash cos x is equal to g of x. That is question number 2. Equation number 2. Now we solve question number 1 and question number 2. We solve 1 and 2. We get v1 dash cos x into sin x. We multiply equation number 1 by sin x plus v2 dash sin x into sin x, sin square x is equal to 0, and we multiply equation number 2 by cos x. So minus v1 dash cos x into sin x plus v2 dash cos square x is equal to g of x into cos x. This part is omit, so v1 dash is common. So v1 dash into sin square x plus cos square x, that is 1. So v1 dash is equal to g of x into cos x. Therefore v2 is equal to integration 0 to x cos t into g of t dt. Now from equation number 1, v1 dash cos x plus v2 dash means g of x into cos x. So v2 dash g of x into cos x into sin x is equal to 0. So we take cos x as common, cos x into v1 dash plus g of x into sin x is equal to 0, or v1 dash is equal to minus sin x into g of x, or v1 is equal to minus integration 0 to x sin t g of t dt. Therefore yp is equal to, that is particular integral, is equal to v1 cos x, v1 into cos x, that means minus 0 to x cos x into sin t g of t dt, v1x into cos x plus v2x into sin x plus 0 to x sin x into cos t into g of t dt is equal to 0 to x integration 0 to x sin x cos t sin x cos t minus cos x sin t whole into g of t dt is equal to integration 0 to x sin a cos b minus cos a sin b, that means sin a minus b into g of t dt. We get the particular integral. So therefore y of x is equal to complementary function plus particular integral, that is complementary function is a cos x plus b sin x, plus particular integral is integration 0 to x sin x minus t gt dt. Now we apply the given conditions. Y of 0 is equal to 0 and y dash 0 is equal to 1. So from y of 0 is equal to 0 we get cos 0 means 1, so we get a sin 0 0 plus 0 to 0, this part is also 0, so y of 0 is equal to a is equal to 0, and y dash x is equal to b cos x, and that is, if we integrate this part we get sin x minus x into g of x into dx by dx is equal to b cos x plus sin 0 means that was, this part is 0, so y dash 0 is equal to b into cos 0 1, so y dash 0 equal to b is equal to 1. Therefore y of x is equal to a is 0, b equal to 1, so yx b equal to 1 sin x plus 0 to x sin x minus t g of t dt. So this is the correct answer, and therefore option Option B is correct. Thank you.